So if you look at this slide now, there is a use of second law. Second law helps us to find the maximum possible efficiency of heat engines and coefficient of performance of refrigerator systems and heat pumps. Right? So that means maximum what can be done in heat engine we can find out from second law, and what is the maximum performance which can be achieved in a refrigerator or in a heat pump. And it also helps us in identifying the direction of the processes, in which direction the transfer will take place. So let's take an example. An inventor claims to have a heat engine that will use the temperature difference between the top and bottom layers of a lake. So this is a lake. Top temperature is 25 degrees centigrade. Bottom temperature is 15 degrees centigrade. And he says that it can produce 1 megawatt of work for centuries continuously, because solar energy is there. You can get so much solar energy per square meter, which heats this temperature water to 25 degrees centigrade, and bottom temperature is 50. So there's a delta T here, and he says that I can generate 1 megawatt of work continuously. Is this person telling the truth? You need to find out, right? So this is what is given. Area of the lake is 10 to the power of 4 meters square. Solar energy flux is 240 watts per meter square, and temperatures of T hot is 25 and T cold is 15 degrees centigrade. So first law analysis, we are saying that this is our source, 40 watts per meter square, and QH QH is 240 watts per meter square into area of the lake, which is 2.4 megawatts. That is the source, that is the heat supply or power supply. And he says that I can generate 1 megawatt. So essentially what you're saying is you are going to get 1 megawatt from 2.4 megawatt. So you're not generating any heat, you're not creating any heat, right? Or energy. So this first law is not violated. Second law, what is the best we can hope for? So we can find out what is the maximum efficiency under this temperature difference, right? 25 degrees centigrade, 15 degrees centigrade. That is Carnot efficiency, right? W out upon QH, or 1 minus TL upon TH. This is the equation for Carnot efficiency. If you put temperature T cold or T low is 15 degrees centigrade plus 273 upon T hot is 25 plus 273. What we get is 0.0336 as a maximum efficiency of this Carnot cycle. What is the maximum work we can get out of this? Equal to efficiency into QH. 0.0336 into 2.4 megawatts. So we get maximum what we can get is 0.0805 megawatts. Right? So under these two temperatures, maximum energy which work which can be obtained is 0.08 megawatts. What does it say about this statement? The inventor. Is it feasible? It's not feasible, because maximum you can get is 0.08, and he's saying that I can get 1 megawatts of power. So this hypothesis is not correct. There's no way we can generate 1 megawatt of power from the sea. Right. Any questions, doubts on this? Okay, so I have one more slide here. Sign convention of work and heat, which we discussed, I think, in the last lecture. Just a picture I obtained. So if there is a system, heat input to the system is taken as positive. Heat output from the system is taken as negative. Similarly, work done by the system on the surroundings is taken as positive. Work done on the system by the surrounding is taken as negative. This is the old convention, right? The difference is between the old and new convention is that only this direction changes. This becomes negative, this becomes positive. That's the only difference between the old and new convention. The quantities remain the same. Q is going to remain the same. Only direction, positive and negative tells us direction. Positive means Q positive means heat is added to the system. Negative means heat is removed from the system. In the old convention, positive means work is done by the system on the surroundings, and negative means work is done by the surroundings on the system. The new convention, Q convention is same, only this changes. Work done by the system is taken as negative, and work done on the system is taken as positive. That's the only difference between new and old convention. Numbers remain the same, only the direction, indicated direction is different. Any questions, doubts so far? Okay, so in that case, now we will stop the meeting finally for this session today, and we'll meet again on Monday. Continue with CET2. Okay.